I wanted to finish off the power series section with one last example, something that's sort of all inclusive of everything we talked about so far, and it looks like this: x plus 1 y double prime plus x minus 2 y prime plus y equals 0. And not only that, we're going to have initial conditions. Y of 0 will equal 2. Y prime of 0 will equal negative 1. Now once again, we have to make sure that we can have a power series solutions here. So we look at this x plus 1. X plus 1 equals 0 when x is negative 1. That means it's not 0 when x is equal to 0. So there is a power series solution about x equal to 0. There's some theory I'll talk about in the next time, but there's a little bit more than what I'm saying about just not being 0 there. Anyways, we're going to set, as we usually do, y will equal summation k equals 0 to infinity a sub k x to the k. And then we're going to throw it into the differential equation and see what happens. So we'll have x plus 1. Take the second derivative of this thing, and recall I'll start this series, then we'll start at 2. So k equal 2 to infinity, k times k minus 1, a sub k, x to the k. And then I'll plug it into this piece. This time it'll go k equal 1 to infinity, k, a sub k, x to the k minus 1, and then finally we have just y at the end. And all that's equal to 0. So what I'll do first is I'll multiply through, distribute the series through the x plus 1 and the x minus 2. And I want to go in a step-by-step fashion so as to minimize mistakes. If there's a lot, the ability to make mistakes in problems like this is very high, so you should probably go slower than you probably want to. Like I said, paying attention is important. I forgot to take the x minus to the k minus 2 on that first piece. Then I'll have plus 1. I won't write the 1, but and then I'll move on to this series over here. I'll have another x out front. I'll suck the 2 inside. So I have 2 a sub k x to the k minus 1. And then finally just the plain series itself. And that will equal 0. So let me go ahead and multiply through the x. That'll change this to the x to the k minus 1. When I multiply through by this x, that'll change that to x to the k. So there's this first series here. I'm not going to do anything with this one just yet. Next, I'll go ahead and multiply the x through to this series. And then this series here, well, no, I'm right here. Forgot about that guy. So minus. As I said, you want to be really careful and go slow here. X minus 2. So you have the x and the x minus 2. But do you see this right here? This little k disappeared on me. So let me go ahead and see if I can sneak it in here. That k sub ak, that's important. Alright, I'll go ahead and throw it in there now. 2k a sub k x to the k minus 1, and then plus k equals 0 to infinity a sub k x to the k, and that of course equals 0. Now the next step is you want to look at what the powers all start at. If you look here on this very first series, this starts at x to the 1 power. On the second series, this starts at x to the 0 power. This starts at x to the 1 power. This starts at x to the 0, and this starts at x to the 0. So what I'm going to do first is re-index so that I can have more compatible exponents. So like this one here, if I start at x to the 1 power, if I re-index and change this for k equals 0 to infinity, I'll have a k plus 2 and a k plus 1 here, a sub k plus 2, and then k will of course x to the k, the first x to the k will be x to the 1 power, because I'll change this to x to the k plus 1. Actually, I'm not sure I want to do that, but well, nonetheless, this next one here, I want to definitely re-index this one so that it starts at 0 when k is equal to 0. So let me go ahead and do that right now. So I'm going to circle the ones I'm going to re-index right now. I'm going to re-index that. Anything that starts at 0 but doesn't have an exponent that is just k, I'm going to re-index. Like here, this starts at x to the 0 also. Now you never need to re-index this one. It's always good just the way it is. K equals 0 and it starts at 0. So let me put a little re-index here. I'm going to leave these for a moment because I don't want to do more than one thing at a time. But now, when the second piece, when I re-index that, I'm going to want k to start at 0 and go off to infinity. But remember then, I change this piece to k plus 2 times k plus 1. Don't forget to change this sub k to a sub k plus 2. And then x to the k. And you can always test it to make sure it works out. Here on this series, it started as 2 times 1, a sub 2 x to the 0. And if you look down here, 2 times 1, a sub 2 x to the 0. So it works. I'm leaving this series right here alone for right now. This series, I'm of course re-indexing. So I'll start it at 0. And then the 2, of course, doesn't change. But this k will change to a k plus 1. This a sub k will change to a sub k plus 1. And then x to the k. And then, of course, this series here. And, of course, that all equals 0. I think what I'm going to do at each piece, let me put just a little sort of demarcation line here so I know each time that I'm going to redo something. Now these here, as I mentioned, do start at k equal 1. This is already of a format that I like. Now what you cannot do, you can't start them at k equals 0, but I can change this to an a sub k by re-indexing this first series so that it's x to the k, and then I'll have a k plus 1 k Well, you get the idea. So this first series, I'm going to re-index it, but I'm going to start it at 1. And then a sub k plus 1, and then x to the k. So I'm slowly building up. Everything will be x to the k oriented. Okay, moving on. This guy right here, it has the x to the k and it starts at k equals 1, so I really can't do anything to it. I like the x to the k. Don't forget to put your pluses over here. And then the rest of my series have already been fixed. And that, of course, equals 0. Now, I have this series, and this series all start at x to the 0, and this starts at x to the 1. I cannot back these up to start at x to the 0 because there is no x to the 0 for the first two terms. So what I'm going to do then, of these series now, I'm going to release the first term. Then everything's going to start at k equal 1. I'll put those initial terms at the end of all this. But so when I release a term, this will start now at 1. This is the series. I'm releasing the first term here, so I'm going to start it at 1 now. I forgot to release the terms. Let me go ahead and release them now. When k is equal to 0, I'll have 2 times 1 a sub 2 x to the 0. So I'll have 2 times 1 times a sub 2 x to the 0. For this piece here, I'll have 2 times 1 a sub 1 x to the 0. And then finally, releasing the first term from this leaves me with a sub 0 x to the 0. Of course, all this stuff equals 0, of course. Now notice, everything starts when k is equal to 1. Everything has x to the k in common. So all of this stuff I can write as one big series. Let me see if I can fit it here. K equals 1 to infinity. I'll start. Now let me go ahead and put my coefficients in here. K plus 1 times k a sub k plus 1 plus k plus 2 times k plus 1 a sub k plus 2 plus k a sub k minus 2 times k plus 1 a sub k plus 1, then finally plus a sub k, and all of that is a coefficient for x to the k, plus, and then here I have 2a2 minus 2a1 plus a sub 0, and all of this is equal to 0. Now the way you always work these is you kind of collect everything in front of x to the k, and then inside of here we collect as best we can. I look for some like terms. For example, I see an a sub k plus 1 here, and I see an a sub k plus 1 over here. And notice they even have a k plus 1 in common. So if I take this, my k plus 1, k, a sub k plus 1, minus 2 times k plus 1, a sub k plus 1, that will handle this piece and this piece. I don't have anything attached to a sub k plus 2. But I do have some a sub k's that I can put together. Okay, a sub k plus a sub k, x to the k, plus 2a2 minus 2a1 plus a sub 0, and that equals 0. Now if you'll notice here, let me put my bracket to begin this. If you'll notice here, I have a k plus 1 and an a sub k plus 1 common to both of these pieces. So for that first piece, if I factor out a k plus 1, and if I factor out the back an a sub k plus 1, what will be left is a k minus 2. Now for this piece it had no one to merge with, so it stays. And now here though, if I factor out an a sub k, I'll be left with k plus 1 times a sub k. And all of that is attached to x to the k, plus 2a sub 2 minus 2a sub 1 plus a sub 0, and that's equal to 0. So what we have then is, remember this is like 0 plus 0x plus 0x squared plus 0x cubed. Every single coefficient we set equal to 0. So we set these three guys equal to 0, because this is the constant term, which is 0, but then we have all of these that we set equal to 0 as well. So this piece right here is really simple. 2a sub 2 equals 2a sub 1 minus a sub 0. What's different about this series, if you'll permit me to go back up to the top and to the original statement of the problem, is this. You're going to find that this happens here. I have variable coefficients on y double prime and y prime, and then there's also a y. So what's going to happen here is the way your numbers are related to each other, your a sub k's, you're going to have your a sub k's will be in terms of two previous a sub k values. Let me divide by 2 here. A sub 2 equals a sub 1 minus 1/2 a sub 0. And then let me go ahead and set this whole thing equal to 0. All of that stuff's going to equal 0. Notice that there is a k plus 1 attached to everything. So I'm going to divide everything by k plus 1. No worries there, since k is greater than or equal to 0. None of these are 0. And then as I did up here, I'm going to take the a sub k plus 2 and rewrite it in terms of the other things. So I'll have a k plus 2 times a sub k plus 2 will equal, when I take the k, a sub k plus 1, it'll be the negative of this, but if you don't mind, I'm going to just write it as 2 minus k, a sub k plus 1, and then I have minus a sub k. Then finally I'll divide by k plus 2. So this will be our recurrence relation, if you will, that will generate the rest of the coefficients after A2. Of course, let me pause for a second here. Our answer will be something like this. It will be something like y equals a sub 0 y1 plus a sub 1 y2. Of course, a sub 0 and a sub 1 are serving as the constants. And you can see them here. They're going to generate everything we need. The way you work this is, I'm not actually looking for the constants. I'm just looking for the y1 and the y2. So what I'm going to do is I'm going to start by allowing a sub 0 to not equal 0, but a sub 1 to equal 0. So this will allow me to figure out what my y sub 1 is going to be. And then I'll reverse this when I need to find my y sub 2. You'll see how it works. First of all, we have this locked down. So let's take care of the a sub 2. A sub 2 will equal, now since a sub 1 is a 0, it will equal negative 1/2 a sub 0. And then I'll use this relationship here for the rest of my values. So we'll start then. I think it's easiest if you keep track of your k values while you're doing this. So if k is 1, I'll have a sub 3 will equal 2 minus 1 a sub 2 all over 1 plus 2 all over 3 minus 1 over 3 a sub 1. Of course, the a sub 1 is equal to 0, and that will give us then 1/3 a sub 2. However, a sub 2 is negative 1/2 a sub 0. And as before, I'm going to keep track of these things in case a pattern should occur that I want to use. Next, let's move on to k equals 2. I'll probably do this for a few, see what happens. So I'll have a sub 4 will equal 2 minus 2 times a sub 3 all over 4 minus 1 over 4 a sub 2. Now a sub 3 right here is negative 1/6 a sub 0. So I'm going to have, let me get this before I do anything here. Oh, it doesn't really matter. My bad. The a3 doesn't matter because 2 minus 2 is 0. So we just have negative 1/4 a sub 2. And a sub 2 is negative 1/2 a sub 0. So I have 1 over 4 times 2 a sub 0. K equal 3, I have a sub 5 will equal 2 minus 3 times a sub 4 all over 5 minus 1 over 5 a sub 3. So I'll have negative 1/5 a sub 4 minus 1/5 a sub 3. what I'm going to do is, let me see, what did I have for a sub 4? I can replace that with 1 over 4 times 2a sub 0. So I have negative 1 over 5 times 4 times 2a sub 0 minus 1/5. And then a sub 3 was negative 1 over 3 times 2a sub 0. So I have times 3 times 2 a sub 0, and this becomes a plus. Now, when trying to simplify this, what I'm going to do is factor out the 1/5, and the 1/2, a negative even. So I'm going to do a negative 1 over 5 times 2 a sub 0. And what that will leave me with is 1/4. Since I took out a negative here, minus 1/3. And when you do this, you'll get negative 1/12. 3 minus 4 will be negative 1, so I'll have 1 over. Now, instead of putting a 12 down here, 12 does factor as 4 times 3. So, as I said, I'm always in the lookout for a pattern of some sort. And I think I'm going to stop there because I do have terms up to a to the 5. So, for my first piece, y sub 1, remember, that's going to start at a sub 0, because I'm doing a sub 0 is not equal to 0. So my y sub 1, remember, I factor an a sub 0 out of everything. The very first term in these is always 1. And then my a sub 2 was negative 1/2 a sub 0, so I'll have negative 1/2 x squared. And then I do have an x cubed term, negative 1 over 3 times 2 x cubed. Do I have an x to the 4th term? I do. 1 over 4 times 2. And I even have an x to the 5th term, and that's this one right here. It looks like plus. Now, if I had to guess, I'm guessing this goes, the next term will be negative. It may or may not be. I'll put a plus because I don't know that, but it does go on forever. So I think I've given enough here. I just don't know that I have any kind of a pattern emerging here. If I drew out some more terms, maybe I would see the pattern. But there is y sub 1. There's half of our solution. Now for the other part. Now set a sub 0 equal to 0, but a sub 1 we will let hang around. And now we'll redo the process, and that will give me my y sub 2. So what I'm going to need again is this here. Let me grab it. And we also had this here. Now, since a sub 0 is equal to 0, I have a2 will equal a sub 1. And then for the rest of the things, I'll use this up here. So I'll start with k equal 1. And once again, that'll start me with an a sub 3. And that'll equal 2 minus 1, a sub 2, all over 3, minus 1/3 a sub 1. And then I get 2 minus 1, I'll get 1/3 a sub. Now a sub 2 is the same as a sub 1, so I'll change that. And so a sub 3 equals 0. When k equals 2, I have a sub 4 equals 2 minus 2, a sub 3, all over 4, minus 1/4 a sub 2. The 2 minus, it didn't even matter if that 2 minus 2 is 0, the a sub 3 is 0 anyways. I have negative 1/4 a sub 2. And a sub 2 is the same as a sub 1. So I have negative 1/4 a sub 1 k equals 3. I think that's about as far as I'll go. A sub 5 equals 2 minus 3 a sub 4 all over 5 minus 1 over 5 a sub 3. Of course, the a sub 3 is equal to 0, so it doesn't really matter. Here then, I will get negative 1/5 a sub 4, and I know that a sub 4 is negative 1/4 a sub 1, so that'll be 1 over 5 times 4 a sub 1. Now, since the a3 term has zeroed out, I'm going to do one more term just for good measure. K equals 4. A sub 6 will equal 2 minus 4 a sub 5 all over 6 minus 1 over 6 a sub 4. 2 minus 4 is negative 2, so I'll get negative 1/3 a sub 5 minus 1/6 a sub 4. A sub 5 is 1 over 5 times 4 a sub 1, so I'll have negative 1 over 5 times 4 times 3. And the a sub 4 is negative 1/4 a sub 1. And as before, in order to simplify this, now I'm going to think of this 6 times 4 a little bit differently when it's for factoring purposes. 5 times 4 times 3 a sub 1 minus 1 over, I'll think of 6 as 3 times 2, so I have 4 times 3 times 2 a sub 1. And I'll do like I did before. This time I will factor out negative 1 over 4 times 3 and an a1. What that will leave me with is 1/5 plus 1/2. Sub 4 is negative 1/4 a sub 1 plus, there it is again, plus. Then I'll change this to minus. Unbelievable. Here then, when I do this, I get 2 minus 5 all over 10. 2 minus 5 equals negative 3, so what I can do is make this a plus, take that out with that, and then it looks like I'll have 1 over 10 is 5 times 2, so I can do 5 times 4 times 2 a sub 1. I think that's enough. Let's go ahead and write our y sub 2. So y sub 2 will start at x to the 1 power because a sub 0 is equal to 0 right now. So a sub 1 is times x to the 1, and a sub 2 is also equal to that. So this series for y sub 2 is going to start off at x plus x squared. And let's take a look at the rest of the things that we have. A sub 3 is attached to x cubed. I don't have an x cubed term, but I do have a negative 1/4 x to the 4. And then let's see about x to the 5. Here we are. I have 1 over 5 times 4 x to the 5th. And then I have the x to the 6th term. It looks like it has a similar format in some sense to the previous term, to the previous series, which the next thing will probably be a minus, but I don't know. So here's my answer. Y will equal a sub 0 times plus a sub 1 times a sub 1 times this stuff And let me go back up and retrieve the stuff that was attached to a sub 0. And all of that stuff, we come back. There it is right there. I'll just go ahead and copy it in. And it was reasonably nice to me there. And there's your series solution for this particular problem. Now we're not done yet. There were two initial conditions. The one we had starting with y of 0 equals 2. These are not going to be as bad as you think they are to plug in. If you look at y of 0, all of these x terms disappear. All of them disappear. And all you're going to be left with is a sub 0. So 2 equals a sub 0. Well, that's nice. Now, on the other hand, we had y prime of 0 equals -1. So let me go ahead and take... Now notice this a sub 0 is equal to 2. So y prime is going to equal the 2 that's out there. When I take the derivative, then I'll get -1 or x. I don't care about any of the other stuff because everything is in terms of x. When I plug a 0 in, it's all going to disappear. And then when I take the derivative of the second piece, I'll get a 1 plus 2x. And then again, it won't matter what is left there. So when I plug in 0 for x, this whole piece zeroes out, but this other piece will just be a sub 1, and these weren't nearly as bad as you thought. So my total answer then, I'm going to replace my a sub 0 with 2. And that will finish off the problem.